Hi, my name is Patrick Sullivan, and I'm an assistant mathematics professor at Missouri State University. And I'm just responding to some of the dialogue out there right now related to Common Core and a new way of doing math. And before I get into that, I want to just kind of dispel a couple maybe misconceptions. First of all, Common Core itself is a set of learning standards. It's not a curriculum, and it's not a prescription of how to teach topics. What we're seeing a lot in mathematics, a lot of the rants that you see on Facebook are just records of student thinking, and it's being tied to Common Core. But it is related to what we know about how students learn and understand, operate basic operations. So, why can't we? What I hear a lot from parents is, why can't we just do it the way we learned? Well, the old way was built on speed and efficiency. We didn't have a lot of technology when we were learning these methods, so we were looking for the fastest way and the most accurate way to perform a lot of computations. Well, now if we want speed and efficiency, we have technology, we have calculators, we can get those out. The new way of thinking about a lot of these things about learning, it has to do with flexibility with numbers, it has to do with mental strategies, and just a deeper understanding of the why question. Again, if we want students to truly understand the mathematics, we need to respect and value their thinking processes. This is an example of what a lot of school districts are sending out right now. It's just some addition strategies are being used in the early grades. And again, I think for a lot of parents, this is like me trying to read sheet music. It's just a set of symbols, and it leads to a lot of frustration unless there's some clarity to what's being asked. And my goal today is to share with you some of the underpinnings of some of these strategies that are commonly being associated with addition strategies and subtraction strategies, and they're being shared with parents a lot of times, and parents are very frustrated because they don't feel like they can help their kid, which I totally understand. So let's talk about a few of these. First of all, this is the first one that was on the sheet that I just shared with you. Splitting by place value. Well, let's think about, I'm using right now Unifix cubes. This is 10, 2 10s, 3 10s, 4 10s, 5 10s, 6 10s, and 7. So I have 67. Now I also have 1 10, 2 10s, 3 10s, and 8 units to represent 38. So if a student's splitting by place value, they're focusing on the tens and units. So if I do a little manipulation here, what they'll do a little regrouping. They'll put all their tens together, and the ones together, which you'll notice that if I put those together, I can create another 10. So I really have 10, 20, 30, 40, 50, 60, 70, 80, 90. Another 10 for 100, and 5 more, which is for 105. So we had our 90 right here, and another 15. And we've seen students use that strategy to do these type of problems. Okay, let's look at the next problem, or the next type. This is one that gets a lot of play on Facebook and a lot of parent rants. And the point again I want to make is that this is a record of student thinking. So let's again think about this student. So the student, again, as before, has taken the first number, 67, okay, and then they're being asked to add 38. So what they'll do is they're at 67, 77, 87, 97. I'll take 3 more off to get to 100. And then the last group, 205. Again, that's another strategy. Again, as I said before, this is one that gets a lot of conversation going on Facebook. And it's, again, what you see here is just a record of students thinking. And a lot of times what we see Students with the manipulatives will actually do this strategy and perform this strategy, and sometimes, many times, it's without instruction. Okay, the next strategy that you see is 67 is adding it up. So what a student will do a lot of times, again, as before, we have our 67, and instead of adding 38, they'll bring 2 more in. Actually, what they'll do, they will take, remember what we had over here, we had 38 here, and what the student will do many times, working with numbers that they understand better, they'll take 2 from the units digit of the 67, create another 10, and then again you see 65 plus 40, and for the student they will quickly do the work in their head to get 105. But again, you see it 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 105. Okay. Sometimes we call that a compensation strategy as well, where they'll take one grouping and move to another so they can make a group of 10. And again, with friendly numbers, again, we have our 67. And again, we have our 38. Make sure I have 38 here. And you can see it on the screen. But once again, you will see students again. These are their strategies, so sometimes they'll take the 60, which is easy for them to mentally do. And they'll just add the 38, which they'll quickly get the 98 because they have 9 10s and 8 1s. And then they'll add on the last piece to get to 105, which is 7 more. They have their 98, 99, 100, 101, 2, 3, 4, 5, 105. So again, another strategy that you will see students use. And it's called the friendly number strategy. The block's messed up a little bit here. Okay. Next strategy, break it down. I've got a connection to Taylor Swift here. So again, we've got our 67. There's our 67. And again, you see this similar to a strategy, but again, it's a recording of what they're doing. So here's the 37 again. And again, all they're doing, they have their 67. And again, this is a little bit like what you saw on the number line. But again, here we go. 77, 87, 97. Easy to get to 100, make 100 in this case. And then we have 105. So we've actually moved it to here. So again, you can see it come out. The students, it's very easy and visible for them. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 105. And again, the last one on the page was a number sentence. Again, the modeling is very similar to the splitting by place value I showed earlier. It's just a student who's choosing to write down the numbers as opposed to showing what they did with the unifix cubes. So let's talk subtraction now. Okay, and we're going to deal with that a little bit differently here. And instead of the unifix cubes in this case, I'm going to have to be a little strategic here. But I'm going to use base 10 blocks. These are called flats, and they represent, you can see that there are 100 little cubes on each one, 10 by 10. I'm going to try to squeeze 6 of those on here. So that's going to represent my 600s. Okay. And then I have my 710s. I'm going to try to squeeze those over on the side so you can see them here. And again, these are in groups of 10. We call these rods. And rods represent 10s. Running out of room here. So what I have done is I've represented the number 674 by its place value. So I have 600s. I have 7 10s, 1, 2, 3, 4, 5, 6, 7, and 4 units. 1, 2, 3, 4. So how are we dealing with this in terms of a friendly number process? So that's one way to do this. So what we can do, instead of taking away 328, we start by taking away 330. So what I have is, you can see this, so I'm going to take, it's going to be easy and visible in front of me. So I take 100 away, I take 200 away, I take away 300, and I take away 330. So now you can visually see right now that I have 344. But the problem is I took two too many away, so I need to bring back 2. I took away 330 as opposed to 328, so I have a value of 344, which you can see, but I need to bring 2 more back to show that I'm taking away 328 as opposed to 330, and you can see again that I have an answer of 346. So 100, 200, 300, 110, 210, 310, 4 tens, 1, 2, 3, 4, 5, 6 units. So you can kind of see how that plays out. All right, next strategy. And bring everything back. So partial difference. Okay, you can see this is a 3-step process based on subtraction within each place value. So again, I'm going to start with my 674. And again, as before, my subtraction problem, this is a partial difference strategy is what it's called again, is I'm taking away 328. So I'm going to take away 300s, 1, 2, 3. Okay. Now I'm going to take away 2 10s, 1, 2. And I'm going to take away 8, but I don't have 8 units, so I'm going to decompose one of my 10s, and I'm going to replace it with 10 ones. So 1 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've decomposed that 110 into 10 ones, and I'm going to take away 8 because that's what I have in my last unit, or in my last place value. So taking these 4, and I need to take 4 more. So as you can see, the answer is 346, 100, 200, 300, 110, 210, 310, 410, and 6 units. And you can see that play out here as well. Okay? So, keep moving along. All right. Very similar strategy to before, but maintaining the difference. All right, so again, let's look, instead of, we can adjust the subtraction problem. Again, this really speaks to the flexibility of numbers and students' ability. Again, with subtraction, we want to keep the distance between the numbers the same, and we have an equivalent problem. So we'll start out with 676, 10, 20, 30, 40, 50, 60, 70, 674. And there's my 4 again. Okay. Now I'm being asked to subtract 330, but again, just to make this easy on myself, I'm gonna say I'm gonna subtract 330 instead, but I'm also gonna give, because I'm taking away 2 more, I'm going to add 2 more to what I have. So now, instead of 674 minus 328, my new problem is 676 minus 330. And then again, the action's very easy. So I take away my 310s, my 300s. And then I take away my 310s, 1, 2, 3. And done. Again, you can see the answer again is 346. 300s, 4 10s, and 6 units. Okay. Now again, this is just a record of student work. This one here, again, is one that we did some differently, or we did similarly earlier. Again, it's what the student chooses to record. This is just a record of their thinking. This was modeled earlier. Okay. And the last strategy related to subtraction is called counting up. In this case, I take the number 328. I'm going to work my way up to 674. A lot of times you'll see this also done as a record on a number line as well, but we start with 328. So I start there. Where's my... Okay, there's my 328. So I'm going to work up to 674. So I bring in 1, move these over here again, 2, 3. There's my 300 that I brought in. And right now I'm at 628, and I want to get up to 674. So I'm going to add another 40. 1, 2, 3, 4. So right now I'm at 100, 200, 300, 400, 500, 600, 610, 620, 630, 640, 650, 660. And these are hard to see. I'll bring them up here. I have 368. I need to get to, I have 668. And I want to get to 674. So I bring in 1, 2, 3, 4, 5, and 6. And again, as I did earlier, I can decompose, but you can see that I've brought in 346. And again, if I want to illustrate this as I did earlier, I can take these 6, these 4, decompose or compose the 10 ones into 110, and I have 674, which puts me where I wanted to get to. So those are the different addition strategies and subtraction strategies that we see students many times with very little instruction perform. In fact, we're seeing first graders and kindergartners able to do some of these more complex type problems because of the representations that we're putting in front of them and the type of work that we're asking them to do. So again, my purpose in this video was to educate parents as to some of the things that we're doing to help students learn mathematics and make a connection between what we're doing with the representations and sometimes, many times, what the record is actually showing and being sent out to parents. In the end, I hope this was helpful. Thank you and have a wonderful day.